Hello. In this lesson, we cover the topic of direct and indirect proportionality. Consider two quantities which changing with respect to each other, and when one of them is zero, the other one is zero. And when one of them doubles, the other one doubles. When one of them triples, the other one triples, and so on. As an example, when you're turning centimeter to millimeter, you always times by 10. So what this means, when you measure a quantity, if its length is 0 in centimeter, it's going to be 0 also in millimeter. If it is 1 centimeter, then will be 10 millimeter. You times by 10. If you double the number of centimeters, you become 20 centimeters, 2 centimeters, sorry. That will be the number of millimeters also will double, so it becomes 20 millimeters. So that is an example of direct proportionality. As another example, when you buy, for example, any grocery, for example, fruits, if you're buying apple and it costs $3 per kilogram, then when the weight of the apple is 0, the cost also is 0. But when you know the weight of the apple, for example, if it is 4 kilos, you need always times it by 3 to arrive at the cost. So if we show the cost as U and the number of kilos of apples as A, so U, the cost is always 3 times the number of kilos of apple. This number 3, as you might remember, is the gradient. Or in this case, we call it the constant of proportionality. Okay, so gradient and constant of proportionality are the same thing. Now, if we sketch them, if we sketch the cost of apples versus the weight of the apple we buy, when the weight is 0, the price you're paying is 0. But say when the weight is 2 kilogram, the price you're paying is $6. So that is, for example, 1 point on your graph. So 2 kilogram means $6. So that's the point. 2 kilogram, $6. That's $4, that's $8, halfway between them is $6. And then if we connect this point on the line with this one and continue, that will give us the whole sketch. Now you can use it to find the price for any given number of kilos. For example, if it is 4 kilos, I go up from 4 and I hit the line and I go across and it gives me $12. So for 4 kilos, I need to pay $12. Or vice versa. If they tell me we paid, for example, $18, how many kilos did we buy? I start from $18 on the cost, come across to hit the line, and then come down to read the kilos. So we have purchased 6 kilos. That is an example of direct proportion. So when one quantity is 0, the other one is 0. And the graph is going to be a straight line, and one quantity is always equal to a constant number, which is constant of proportionality times the other quantity. As we said, in this case, the constant of proportionality was 3. To look at an example of an indirect proportionality, first of all, an indirect proportionality is not going to be a straight line. As you can see, it is a graph like this. Secondly, when one of them goes up, the other one goes down. Unlike this one, when the kilos were going up, the cost also was going up. Here, it is other way around. When this goes up, the other one goes down. This showing the amount of fare that you pay when you rent a bus. For example, imagine that you hire a bus for a day for $1,000. And now if 10 passengers are on that, and like you get with a number of your friends and hire this bus, you pay $1,000, but because there are 10 of you, you're going to share it, and each of you pay $100. Now, if you manage to get more people on the bus, for example, 20 people, so the number of passengers has increased, now each of them are going to pay less amount, like $50. So what happened? The number of passengers went from 10 to 20, it increased, but the fare that each passenger pays went down from 100 to 50, and so on. So that graph shows this. We don't get too much details about that. Just remember that it is not a straight line, and as one goes up, like the number of passengers, the fare for each of them goes down. That's called indirect proportionality. Okay, let's complete a number of examples. Example 1, write a rule that relates number of kilometers, k, to meters, m. So you measure something in meters, and you want to see how many kilometers it is. And what you need to do here, you need to times it by 1,000. So I should rearrange them. So the number of meters will be equal to 1,000 times the number of kilometers. Okay. So if you measure something in kilometers, for example, it becomes 5 kilometers, you want to change it to meters. To say it in meters, you got to times it by 1,000. So 5 times 1,000 becomes 5,000. So that is the number in meters. And here the constant of proportionality is 1,000. Okay, the constant of proportionality is 1,000. Just be careful that if I wanted to write kilometers in terms of meters, that would have been 1 on 1,000 times meter. In other words, I'm dividing meters by 1,000. Timesing by 1 on 1,000 is the same as dividing by 1,000. So yeah, the order matters. So which one comes on the left-hand side does matter. All right, that is first example. Second example, your wage W is $100 for 8 hours of work. So you work 8 hours, and you get paid $100. And here we are talking about wage, which is we showing with the word with the letter W, and the number of hours, which we show with the letter H. Now, is it an example of direct proportionality? Yes, it is, because if the number of hours is 0, if you work for 0 hours, you get paid $0. So they both start from 0. And then the more you work, the more you get paid. So both of them goes up by the same amount, and the amount you're going to get paid is your hourly rate times, always your hourly rate times the number of hours will give you your wage. Okay, so we have an example of direct proportionality. Now the first one is saying find the constant of proportionality if we need to write W in terms of H. So basically what we are going to do, we are going to write W equal to a number, I'll just write a number, a constant of proportionality, times by H. So we want to find this number. This is the constant of proportionality. So what we do, they told us your wage was $100, so I write this $100 for W, then equals the number. The number is constant of proportionality. I called it K here. K, then times by the number of hours. For $100, you worked 8 hours, so times by 8. Now from this equation, we can work out the value of K. Because K has been times by 8, divide by 8. So you end up with K here, because K times 8 and divided by 8, you go back to K, and 100 divided by 8 is 12.5. Now we got the constant of proportionality, 12.5. Now in part B, they are asking us to write W in terms of H. Now we have the constant of proportionality. We can do that. We said W is equal to constant of proportionality times H. So W is equal to 12.5 times H. We don't need to put times. And when you're writing it in this form, it automatically means times. C, find the wage if you work 40 hours. Now we are going to use this to find how much is the wage if the number of hours you work is $40. So H equal to 40. So what you're going to do, you're going to replace H with 40 here and put back that times. So 12.5 times H, which is 40. And 12.5 times 40 is 500. In part D, they are asking find the number of hours you need to work to make $1,200. So you need to make $1,200. How many hours you need to work? All right, we write the equation that we had, or the rule that we had, and now we know W is 1,200. So I'm going to write it here. So I'm going to write 1,200 equals to 12.5 H. So in this equation, we replace W with 1,000 because W is wage and we want the wage to be 1,200. All right, so you need to solve this equation again. H has been times by 12.5, divide by 12.5. You go back to H, and this side also you need to do the same, divide by 12.5. 1,200 divided by 12.5 is 96. So you need to work 96 hours to make $1,200. Thank you for your attention. See you in the next lesson.